Hi everyone, welcome back to the channel Code with Rajeshwari. In this channel, we are diving into some exciting iOS development topics. Whether you are new to coding or looking to level up your skills, you are in the right place. Let's get started. In today's Swift tutorial, we are diving into one of the simplest sorting algorithm, which is a bubble sort. If you are learning data structures or preparing for interviews, this is a great place to start. So exactly what is bubble sort? It's a simple comparison based algorithm. The idea is to repeatedly compare adjacent elements and swap them if they are in the wrong order. Imagine building the largest number to the end just like a bubble rising to the top. Let's say we have this array 5, 1, 4, 2, 8. First pass 5 and 1 are compared and then swap. Then 5 and 4, then 5 and 2 and 5 and 8. Biggest number is 8 is now at the end. We keep doing this until the whole array is sorted. Here we are using two for loops, which is the outer loop controls how many times we go over the array, and the second one is inner loop, which compares and swaps adjacent elements. We subtract I each time because the last I elements are already sorted. If you see here, I am just trying to use a if statement here within an array which I have declared in line number 6, and I am just taking the I and j values to compare with each of these, and array of j equals to array of j plus 1. Here I am just trying to get the largest number. This will print the array before and after sorting, simple, clean and effective. Keep in mind, bubble sort isn't the most efficient, it's time complexity, but it's a great way to understand how sorting works conceptually. So, if you see here, there is an error where I have not expected to return an integer, and here I am going to return the value an array of an integer. If you run this program, let's see what I'll be able to see as an output. And I'm just declaring an unsorted array at line number 23. I'm going to give the number of integers here 4, 3, 8, 1, 7 and 0, and let me call this bubble sort function, and I'm passing this unsorted array, so that if you see in the console, I have seen the output as 0, 1, 3, 4, 7 in an order array. And the second one is merge sort. Merge sort is a classic divide and conquer algorithm. Here is how it works. First, we'll divide the array into halves recursively and conquer by sorting each half, and then combine them in the correct order. It is very efficient. The time complexity and space complexity will be also very less. It's a stable sort, which means it preserves the order of equal elements. If you see here, I just declared a numbers array which I have declared in line number 2 with 38, 27, 43, 3, 9, 8 to 2 and 10, which are integers. And I am creating a function which is a merge sort. And here, if you see, let's take an example. Think of a merge sort like a sorting a deck of cards. You break the deck into smaller pieces and sort each pile and then merge them one by one in a sorted array. So let's walk through a quick sample example with the number array which I have already declared. First, what we have to do here is split into three elements which are 38, 27 and 43, and then 3, 9, 82 and 10. This way, we have to keep splitting until we get a single element here. Start merging and sorting with 38, 27 and so on. Eventually, merge everything into a fully sorted array. We use recursion to split the array and then merge the result into a sorted array. Notice how the merge function handles the comparison logic. Here if you see, with these kind of splitted arrays, I will directly see the sorted array at the final. This will be a clean and nice way to use the merge sort. So if you see here, I have declared a left array and right array with the indexes taking from what I'll be going to pass in the next function for the merge sort array. So this is how we have to split the arrays into two different ranges. One is with left array, one is with right array. And if you see here, and I'm going to return a merge with left array and then a right array. Let's create another function for logic to add the merge function. So when we should use merge sort? So basically when stability matters, suppose you are having a multiple integers array or multiple data structures. So at that time when the stability matters, right? At that time we have to use merge sort for larger database when memory is not a major constraint. But for small or nearly sorted arrays, insertion or quick sort may be faster, and that's the merge sort in Swift. If you see here, and at line number 13 I have created a merge functionality with a left and right integers array, and initially I'm declaring as in left index as 0 and right index as 0, and creating a sorted array and creating a while loop. So we'll be having a while loop here to control the logic. And if you see left indexes, and I'm taking the count of the particular integer of the left array and taking a right index with count. Initially the count of the left index and right indexes are 0 here, and we are comparing with these two left and right indexes, adding an if functionality to know how we'll be getting the merge sorted list array, so that we'll be controlling how we'll be having the sorted array elements. And once I get that left array index, I'm going to pass this to sort index and appending to the left element, and then increasing the value of indexes to 1. Else part have to be printed with the sorted array and appended to the right, initially taking and comparing with the left index and then right in the else statement. If that is true, then it has to be the right indexes and appending with +1. That's it. So finally sorted array and appending all the elements to the context of left and right indexes with the particular range here. And so when exactly we have to use this merge sort? So take an example when stability matters. If you are using a large number of elements you will be getting from the database and you wanted to do the sorting without having any interruptions, at that time you can go for merge sort. And for large data sets also it will be useful. And then if you see in line number 29, I'm returning the sorted array. Let's create a simple array and pass it to the merge sort, and let's see how the count and array will be printed. And as I have taken the numbers integer with the 38, 27, 43, 3, 9, 82 and 10 as indexes, in the left array I'll pass this 38, 27 and 43, and in the right index I'll pass the remaining elements which are 9, 82 and 10. And finally the merge functions will get called to see and get the output. Let's print it how sorting works and see it in a visual way. If you see here, let's just pass it and create a merge sort. I am passing this array with the numbers and printing here with the numbers. If you see here in the console, let's run it, the line number 33. If you run this, I'll see 3, 9, 10, 27, 38, 43, and 82, because I have used this merge sort, right? So that's the reason. Uh, in the line number 28, if you see, we have only 5 elements. It's been sorting, and then it works like this. Now we'll be going to discuss about how the quick sort works. So basically, quick sort is a divide and conquer algorithm, just like merge sort, but often faster in practice. Here is how it works. Pick a pilot element, divide the array into three parts. First is elements less than the pilot and elements equal to pivot and elements greater than the pivot. So recursively sort the left and right sides and combine the results. Imagine you are organizing books by thickness. You pick a medium sized book as a pivot. You place all thinner books to the left, thicker ones to the right. Then recursively do the same for each side until everything is sorted. We use Swift's filter method here to divide the array. It's a clean and readable, perfect for small to medium sized database. However, keep in mind this version is not in place. It creates new arrays which increases memory usage. In worst case, when the pivot is smallest or largest item every time, you can reduce the risk by choosing a random pivot or using the medium of 3. Want better performance and more usage memory? You can implement in-place quicksort using indices and swaps. It's more advanced but worth exploring if you are optimizing larger arrays. And now that's a quicksort in Swift. If you see here, I'm just creating a simple function to do the quicksort algorithm, and I'm going to have an array with the inout with an integers. And if you see the line number 9, I have created a partition which is like an low and high, and with the array of high where I equals to low, and using a for loop here to get the swapped elements and append it to the right array, and doing the I plus equals to 1 to increase the index count, and finally array dot swap it, which I have got from variable I and with the high integer. And if we see line number 7, if low less than equals to high, let provider index partitions and array with low and high integers. This is how the quicksort works in Swift. And inside here I am taking a quicksort with the array. So array will be, I'm using, which I'll be passing from the input, which is an array, and low as which I'll be getting from an integer where I'll be passing, and doing the same thing for low and high. For initially we have to do for the high integer -1 and the low integers with a +1, so that in an alternative way it will take the inputs and we can see the output in the functions. And let's see how I can see the output in the console, and we can see how we'll be getting the output, and how we'll be passing this. So basically it's new arrays which increases memory usage when the smallest or largest item every time. Maybe we can reduce the risk by choosing a random one, or you can use a medium or 3. So let's pass an array with the numbers. I'm going to take uh, 10 7 8 9 1 5, which is in line number 2. I'm passing this number array, and low with the 0 and high with numbers dot count -1, which we can get the count as -1. If we see here 1 5 7 8 9, we have already seen in the console, where in the line number 30, and That's it. The next one we'll be discussing about insertion sort. Insertion sort is a sorting algorithm that builds the final sorted array one item at a time. It just works like sorting playing cards in your hand. You take one card at a time and insert it into this correct position. Imagine holding a few playing cards. You pick one, then compare and insert it in the right spot among the ones already in your hand. That's insertion sorting action. Here is the step by step to have the logic in place. First, start with the second element. Compare it to the ones before it. Then shift larger elements to the right. Insert the current element into the correct spot. Repeat for the entire array. If you see here, I am just taking a number array with 12, 11, 13, 5, 6. So first what I will be going to do is I am going to take the second element, which is 11, compare it with 12 and shift the larger elements to the right. Means 11 will come in first and 12 will come to the second. So this is how the insertion works. We use a for loop here also from the second element, and inside a while loop where it shifts all larger elements. Once the right spot is found, we insert it as a key. And but it's very efficient for small or nearly sorted database. It's also in place and doesn't require extra memory. So basically, when we have to use this insertion array, we are sorting a small array or the array is almost sorted. These times we can use it. But when memory is limited, avoid for large unsorted database due to performance issues. And that's a wrap up insertion sort in Swift. Let's see how we will be seeing the output here. And I have already added a logic here and added a for loop with a while loop and taking the input elements and declare the function with the inout keyword. Let's see and run this particular program to know how exactly these kind of sortings will work. Let's try to pass the input to the insertion sort. I'm just passing here a numbers array which I have declared in the line number 2, and if I'll try to print these particular numbers. So let's see what exactly we can see it in the output. If you see here, I have got already 5, 6, 11, 12, 13, which is in a sorting array, and just printing these numbers. Let's print. Since I have used this inout keyword, so this will always take the reference of the particular array. And the final one we'll be discussing about selection sort. Selection sort works by repeatedly finding the minimum element from the unsorted portion of the array and moving it to the front. It's simple and easy to follow, perfect for beginners. Imagine you have a bunch of coins on a table. You scan them all, find the smallest and place it in the first spot, then repeat the process with the remaining coins. That's how the selection sort works. Let's take an example here. I have declared the array 1 with different kind of integers, and first I'll pass 10, which is a small element. Here I have declared 1, right? So let's first pass 1 and swap it with number 5. Second, take the smallest of rest, means again 1, swap it with the next position. Repeat until this is sorted. And I have declared a function here in the selection start. I am going to pass an inout array and taking for loop here with index of unsorted array count, and firstly declaring a lowest element variable and passing this particular index here, and then for loop adding with index 2, which I have to get it from index plus 1. If I'll pass here index as 0, the next element I have to receive it, right? So I'm just applying +1 with an unsorted array dot count. So inside I'm just using if loop to swap the elements. If unsorted count of index is less than or unsorted array of count lowest, then I'll be using this index 2 and assigning to the lowest array. So if index is not lowest, then I'm just trying to swap the element with particular index. And finally, I'm trying to return this unsorted array. So when we have to use this, so when we have small data sets, we can use it. And if you have a large arrays, better avoid using this selection or whatever it may be, like intersection. This kind of sorting we have to avoid if you have large number of arrays. So we'll be using, as I already said, outer loop where to place the next smallest element, the inner loop to find the smallest element in the unsorted part. Let's try to explore how we'll be seeing it here. So if you see here in the line number 12, I'll be taking the 28 as an unsorted array. Firstly, get the index of 1 and try to use it with the 28 and get the lowest element and assign that particular index to the lowest. In this way, we will be comparing with these next smallest elements, and this is what the outer loop and inner loop will have to find the smallest element in the unsorted part. If the index is not equals to lowest, whatever will get the lowest index and we are added here, we have to make a decision here whether we have to add and swap at particular index or not. So that's the reason we have to add if condition here in the line number 70. And here if I'll receive an input of 1, so I might be use that with the 28. So that's how we need to do the swapping of elements. And finally we have to return the unsorted array. That's how it works. So let's just try to pass it the array 1 to this selection sort function and see what we will be getting it in the output. If you see here, I have got 1, 2, 3, 5, 8, which is in order way, which is in a selection sort. Within inout, I have used inout parameter. So since I have used inout parameter, this takes as a reference, and the array 1 will also change it to the updated one. Thank you for watching, and I look forward to seeing you in the next video. Don't forget to subscribe and stay updated with all our latest content.